proportions using the idea of similar shapes. This time we're looking at trapezoids, and we are told they're similar. That is what this symbol right here shows. The little squiggle line, that is your similar symbol. If they're similar, then they are proportional. The problem with these two shapes is they are flipped upside down from each other. So just by looking, it's a little hard to tell which side matches which side. Because of that, the first thing I'm going to do is flip the blue one so that it matches the red one. I know how to do that because this statement right here, this is a math sentence telling you which side from the red, which side from the blue matches which side from the red. So the first two, I to j, is the same as m to n. So I'm going to just draw this in the same orientation as the red one and start labeling based on this. So this is my I to j. I to j is the same as m to n, m to n. So I is in the same spot m was. That makes this I. And j is in the same spot n is. So I'm going to put my j here. We just keep doing this. We move now to the next one. So now we're looking at j to k and n to o. N to o is right here. That means j to k is right there. K to L is the same as O to P. O to P here. So K to L is here. And it even flips the other way. L to I is the same as P to M. There's L to I. That should be the same. Good. P to M. Now that I've gotten my letters sorted out, I can just refer back to this original blue one and put those numbers where they belong. The number from I to j is 15. Here's I to j, so I'm going to put a 15 in there. The number from, here's a number, I to L was 5. There's I to L. Let's insert our 5. On the bottom, what was the bottom? L to K, we had the Y, so let's put our Y in the L to K. And notice there's nothing here from the J to K, so we will leave our J to K line blank. So now that we've reoriented our blue trapezoid, I'm going to ignore the original one entirely and just look at these two. So we are asked to find x. This is just like the triangle problems that were already situated for us. There is a process I will go through quickly. Usually there is a big and a small. In this case, I've drawn them about the same, so I'm going to call this a red and a blue. Just something to keep them separate in our minds, and something we can use to label. So if I'm finding x, I need to use a fraction that includes x and its matching side. I could either use x over 15, or, if I prefer, I could use 15 over x. As long as I'm consistent, either version will give me the correct answer. To help me be consistent, I'm going to label this x with an R because it came from the red trapezoid. I'm going to label the 15 with a B just so I remember it came from the blue. I'll do the same thing here. The 15 was blue, the x was red. Okay, you only have to set up one of these. I'm just showing you that both ways work. Now that I have one fraction set up, I need to choose a pair of matching sides that has a number for both of the sides. Here's a 14. Its matching side is y, so that is not my choice for this problem where I'm finding x. I need a pair of sides that have a number on both. There's no number here, so that's not it. Here's a 7, and here's a 5. I do have a number on both, so I'm going to use it. On this top fraction, I put the number, or in our case, the letter. I put what was from the red trapezoid on top. So I'm going to do that again. 7 on top, and its matching side from blue on bottom. If I had chosen to set it up with the blue on top and the red on bottom, I would have to follow that pattern. Blue on top is 5. Its matching side from red on bottom is 7. Okay, we have set this up 2 different ways. You do not have to set it up 2 ways, just one. Once you've set it up, the process to solve any proportion is always the same. We multiply those numbers that are diagonally opposite each other and divide that answer by the number opposite your unknown. So x is 15 times 7 divided by 5. We can look at this other one. We multiply the numbers diagonally opposite from each other, divide that answer by the number opposite your unknown. So again, x will be 15 times 7 divided by 5. Okay, you can see they're the same either way. Let's just go through and simplify. I'm doing this by hand, so I am going to model reducing. 15 goes into itself once. 5 goes into itself once, and 15 divided by 5 is 3. So I have left here x equal to 3 times 7 over 1. 3 times 7 is 21 over 1. This is correct, but it's not fully simplified. There are 1s in math everywhere, so we only write them when we need to remember they're there. 21 divided by 1 is the same as just 21. We would get the same answer here. 15 divided by 5 is 3. 3 times 7 is 21. So as you can see, there are multiple ways to set up a proportion problem as long as you're consistent. Once you've set up the first fraction with the matching sides, you must match that with your second fraction.